In today's lesson, we will reveal the singularity, blow up the 0, how to get the multiplicity of each fiber and its intersection. Finally, I reach here the answer. The whole process, last lesson we already calculated y2 x to the 3 and y cube x to the 4. Today y square x to the 5. Actually, finally, I get a table for the small numbers. And today, my method is different. Here, the calculation is complicated. Finally, I reached a new method called the continuous fraction method. Continuous fraction, here 5/2 can be Euclid fraction. Euclid fraction, first do Euclid division, we can get the multiplicity factor. This factor will be used here. Now we see how to use a tree to represent the Euclid fraction. Okay, here 2. I use 2. There is 2 layers. The first layer, second layer. Second layer, 3. The length. The first layer is only you can see only 1. So 2, we should be very carefully. This 2 is 2. Okay. In this case, when 5/3, 112, 112, 112. Here, 14, 14. That means the first layer is smaller, a little smaller. The 1 unit smaller, 1 unit smaller. Here you can see the first layer is 0, so it's 0 is 1 unit smaller than 1. Here the first layer has only 1 element, is 1 unit smaller than 2. Here is also first layer is 0, so 0 is 1 unit less than 1. The second layer 1. The second layer is normal. The second layer is normal. So you should do it carefully. Okay. Usually the second layer is 3 is 1 unit larger than the number. The 1 is actually this layer has 2 elements. This layer is 3 elements, so 1 unit larger. The first layer 1 unit smaller. Okay, now we get this is the tree presentation of the fraction Euclid. Now we extended this tree, extended by 2, 2, 1, 1 by the multiplicity. We get extended tree. Extended in this extended tree, we calculate here 2, 2, 1, 1. Calculate what should be filled here. What should be filled here? 2. Why I fill 2 here? Because it's the sum of first layer. 4 is the sum of the second layer. 2 to 2. 5 the same. 1 plus 4. 10, 1 plus 4 plus 5. So here 4 inherited 4 the same. Here is also the same. Now finally I get the multiplicity sequence 2, 4, 5, 10. 2, 4, 10, 5. Why I put 5 here? Because this 2 there is 5. 2 is multiplier of 2, multiple of 2, and this 9. multiply over 5, this 9, 2 9s. Here is the tail. The tail is always 1, 1, 1. So finally I get here. You can fill the intersection now. Use the if you know algebraic's rules. Here 2 times minus 2 equals 4. 2 plus 10, 12. 12 equals 3 times 4. Here 10 equals 10 times 1 equals the sum. So each one equals the sum. Each one here equals the sum. Sum times intersection. It was the same. So since it's the case, so here the intersection, because here how to around it is the sum is 18, so it's minus 2, minus 3. 12 or 15, the sum. So, but this will find the intersection, and it's a formal calculation, so I didn't explain why. Just let you be capable to do computation first. The last example, 1 4 1 4 4 1 1 1 4 1 1 1 4 5 10 15 20. Okay, 20. Multiple of 5, multiple of 4. Now fill the intersection. Finished. And it has a bunch of applications. How to do application will explain some discovery did by me. Actually, I write a little paper concerned how to compute log conical threshold. It's a famous notation, it's a famous concept, so I would like to explain. Okay, here C bar equals phi star C plus sigma Ni EI. This is the fibers blow up from 0, 0. This here is the exceptional curves. The conical divisor also should be calculated. Finally, if we do calculation, because the log conical threshold defined by 1 over a plus 1 over b here. I want to define a sequence here. Define a sequence. On the sequence, I will do it from an example. Here the conical. So how to compute the conical? Conical, the multiplicity, the extended part, I use 1 1 1 1. Originally, to use multiplicity, this is 3 5. Okay, the multiplicity is 3 5 1 1 2. Okay, 3 2 1 1. I get this 3 5 9 18 is dominant. Because I through the here I want to search the minimum, seek the minimum of AI plus 1 over BI. Why? This is the minimum of this set. If I verify it's 1 over A plus 1 over B. Here 1 over A plus 1 over B. If I can prove it, that is, to some extent, I verified the log conical threshold the minimization. So how to do it? Because it's 111, so I can 1, 2, 4, 7. 2, 4, 1, 1, 2, 4, 1, 2, 4, 7. 1, 2, 4, 7. The calculation is not hard. So here 2 plus 1, 1 plus 1, 2, 2 plus 1, 3, 5, 8. Correspondingly, to do the quotient, you get a set of fraction. In this set of fraction, finally, we find the last guy is the minimum. So we verified. Other example, I also verified. Actually, I write a paper. Finally, actually, I write a paper because in my doctor says I generate the conclusion, and I use the tree. Look at the tree. There is a two extended tree. Yeah. Extended tree. This example here. I did the tree and final LCT sequence. I calculated. Finally, I get last term. 1 over A plus 1 over B is the minimum. And okay, so finally, I also my main theorem, I also claimed that it's a conclusion the proposition to be verified. The conical threshold of C is P 1 over P plus 1 over Q. PQ what? Because this curve. Okay.